Just thought I'd give you a brief rundown on a Tinkercad simulation I've been working on. This is using a basic servo. We're going to use this potentiometer, which is a variable resistor. It's going to serve as a voltage divider. The voltage will be between 0 and 5 volts as it goes into the analog input A0. And as we vary the voltage using the potentiometer, you can see that there is a proportional change in the servo. So basically we're able to use the servo as an actuator. These servos can be very large, or they can be geared to extremely high precision. And the code for this is available over in here. And you can see I've got the serial monitor up and running. So as I turn the knob, you can see that the sensor position is down to 0 and the value is 0. And then we sweep it all the way up. We get the value up to 1024. This is a 10-bit ADD converter, so it can do 2 to the 10 or 1024 different possible values. And let's get into the code and see if we can explain it a little bit. So we'll close this serial monitor and check out the code. We've got the include on the servo.h and software serial so that we can proceed to output to the serial monitor. We set up our initial position for the servo at 0, sensor value is 0, and this little auxiliary variable is really not needed. We've got an opportunity to use this variable servo9. We could have it called anything we like, but in any case this will be the identifier for this particular servo, and we'll attach it to output pin 9. This is going to serve as a pulse width modulation output. And when we take a look at the wiring, we can see that it is going into the orange wire of our servo. Servos often have color-coded wires. This one probably should have been coded orange, but it doesn't really matter. And then we proceed to use analog input 0. And we've got an output pin here for pin 13. Don't think we are using it here, so we could probably have eliminated it and things would still work properly. Let's just check. Yeah, pin 13 is not doing anything. And then what we'll do is take a look at the pin mode for the analog input that is set as input, because we're going to read the input from the resistor. We'll set up the serial port at 9600 baud, and then we're going to read in the analog value, and that's a value that'll go from 0 to 1023, and we're going to map it to a value 0 to 180. Now if you like, we could try and put in another number, let's say 360 degrees, and see what happens. So this is kind of one of those interesting things you can certainly experiment with in the simulator, which may not work quite the same if you proceed to use a real servo. Sometimes using real servos will give you different results. Let's see what happens when it goes up to 360. Yeah, it looks like he has a hard limit there. So he's only going from 0 to 360, 0 to 180, so it doesn't matter if you put it in a map of 0 to 360. He won't like it. So stop your simulator and revert the code back to 180. And that will work properly. This is outputting, of course, the sensor value and then the position. In principle, you could probably put them both on the same line if you like. Just put a little space in here so that you can separate these things. And then when you go to write this stuff out, there, you can see it's all on the same line. And now when you start to sweep, sensor value goes to 1024 and position goes up to 180. So that's my little demo Hope you like it. This gives you a basic idea of how to use an actuator and a microcontroller to coordinate an input and effect an output. Thanks a bunch. Talk to you later. Bye.